My name is Jenna Albright, and this is my EDT 6005 interactive whiteboard instruction. The title for my lesson is Ratios and Rates. The overall purpose of my lesson is to allow students, learner's choice, to explore these slides and explore the technology provided for them to be able to take charge of their own learning and work at their own pace. My essential questions are: how can you represent a relationship between two quantities? How can you find two ratios that describe the same relationship? And how can you use rates to describe changes in real-life problems? Moving along, of course my overall subject is mathematics, and the topic is ratios and rates. Now this is for a 6th grade classroom since I am overall a 6th grade teacher. My standards are to the right. We have our Common Core standards that are listed with 6 ratio proportions. My ISTE technology standard relates to empowered learning. It is 1C that has students use technology to seek feedback that informs and improves practice and demonstrates their learning in a variety of ways. The 21st century critical thinking or 21st century standard allows students to be critical thinkers and provides opportunities for problem solving, which relates to our instruction as a whole. Taking a look at the pre-assessments, for a pre-assessment I chose an option from the Smart Gallery Essential, which has students identify patterns within tables, and I also included a pre-assessment that relates to almost an introduction to what it is that we're going to be learning through our instruction on ratios and rates, and it is with definitions. The post-assessment is a smartboard game that has students work on their own or with a partner or a group of students based on questions that are related to and are incorporated into our smartboard slides. So let's take a look at what some of the pre-assessments look like. As we move through, students read the directions and it says, using the numbers from the table, identify the rule to place the numbers appropriately. So in elementary school, students were asked to look at tables and identify a rule that represented how the numbers went from one number to the next one. That's all I'm asking them to do within this pre-assessment. So they can drag and drop the number that they think corresponds to what fits in the next pattern. Okay? This gives me an opportunity to see what they know. If we move to the next one, students have the vocabulary words that they can move and sort based on what they have learned previously about these words and definitions. This also provides an introduction to what the lesson is going to be about. Continuing through, moving into part 1, this is the part 1 in the introduction to what our instruction and our lessons are going to be about. The very first part is about ratios, and this is just the definition of what a ratio is. And the next slide provides some parts and some different ways that we can represent ratios. First, we have a part-to-part relationship, which describes the number of squares to the number of circles, 3 to 2. There are 4 different ways that we can represent ratios: using a colon, using the word to, as a fraction, and as a for every statement. The other comparison that ratios provide is a part-to-whole comparison. In this case, we're comparing circles to the total number of shapes, which is 2 to 5. Again, they're given the 4 different ways that you can write a ratio. Moving along, students are given the opportunity to practice writing their own ratios. In this case, we're talking about baseball bats or baseballs to bats. And through this slide, they can actually sort the baseballs and the bats to help them with counting and organizing their thoughts to practice writing their own ratios. So once they organize them, they can practice writing their own. This slide has gives students the opportunity to work with a partner if they would like to, and it also provides them with a way that shows how we can write sentences that compare the two objects. So each of the numbers correspond to the number of calculators up here, and these are infinite cloners, so students can drag them into the appropriate spot. Down at the bottom we can see that they're comparing as a part-to-whole relationship. Now this provides an overall instruction so far about what we are going to be learning within our slides about ratios. So this is the basic information of ratios, and if students are still struggling to understand what a ratio is, they can watch this video that I embedded into their instruction. This is a math antics video. Now they can press play and watch this, and it'll give them an overview of what ratios are, and actually it provides them with an introduction into the next segment, which will be rates. After exploring the basics throughout our instruction of what ratios are, students are now given the opportunity to explore on their own. So at this point, students have learned the basics of what ratios are, and now if they would like to explore through Khan Academy, they can click on the link, and this takes them to the website. Now this entire website gives students multiple videos, reviews, and practice so that they can work through and learn as much information as they need to get them through the instruction of ratios and rates. They can also explore through BrainPop. BrainPop is something that's a little bit more common and familiar with our students, so I could see more students choosing to watch a BrainPop video and take the quiz and make a map. They can do all of these things on their own, which they are actually able to do to make a movie, which is a little bit more collaborative, or play a game once they've learned the ideas. Continuing through, we have some more examples where students can practice writing ratios. For instance, this one is a part-to-part comparison of footballs to tennis balls. The next slide is a part-to-whole comparison for the number of pretzels to the number of snacks. And now students are introduced to a different way to represent ratios through a tape model, which each square represents a number of blue paint in this example. So 1, 2, 3, 4, 4, 2, 1, 2, 3. So they are asked for part A to just fill in the numbers, and as they move through, they are asked to also fill in the words, and by the end they're writing their own comparisons of the different colors of paint. Now they are introduced to a problem-solving problem, where students can use the tape model to help them solve the problem. Now, to provide them with some feedback as they're solving this, I also have given them the ability to move the tape model to see what their answer is to the overall problem in general. Now that we finished part 1 of the basics of what ratios are and how we can represent them, we can now move into part 2, which is equivalent ratios and ratio tables. If students would like to venture off on their own and explore what ratio tables are, they can click the link at the bottom, where they are able to watch a video on finding equivalent ratios using ratio tables. Now if we scroll down, there's also some background tutorials that provide what fractions are with the numerators and denominators, how we can multiply fractions, and what a ratio is, and we can even explore even further in looking at rates, which we will get to even more into our next part of our lesson. Moving along, students are now able to practice on their own. This overall example has students drag and drop the numbers that correspond to the pattern that's represented within the tables. This one really truly relates to identifying patterns in the pre-assessment that students were given. For instance, 5 times 2 gets me to 10, so 1 times 2 is going to get me to 2. This application allows students feedback on what their answer is and if it's correct. So for instance, this one's correct, so it does a spin. If they were to drag an incorrect answer, it would bounce back. That is the case for not only these two examples, but for our next example as well. Students are here to identify the division relationship from 14 to 7 instead of the multiplicative relationship. Again, as they drag their answers, they will spin if they are correct and bounce back if they are incorrect. Now students are asked to use the ratio table to help when solving the problem. I have embedded a ratio table for them to use as they choose to figure out how long it will take Kate to run 10 miles. If students are still confused and maybe they didn't watch the link at first on ratio tables, they are now able to click on that same link to provide them with more information on how we can solve this problem. Finally, we've hit part 3, which describes rate and unit rate. Below is an example where we are comparing dollars to the number of pizza. A rate describes the total number of money, which in this case is $27, to 3 pizzas. And for unit rate, it reduces the ratio down to find an equivalent ratio where 1 pizza, this provides us the cost for 1 pizza. If students would like to watch a video on rate and unit rate to help provide with an introduction, they can click on that or the link at the bottom, which takes us to this page, which was actually where we left off in the last video at the bottom. Moving through, we are given some examples that students can use to check their work. And finally, some real-world problems, which was our last essential question for our goals of this lesson. This last problem allows students to use a ratio table, fractions, or a colon to help them describe the relationship within this problem and find the missing piece. They are not required to use any type of specific way to solve the problem. And finally, now we can look at our post-assessment. I have 2 post-assessments that are embedded into our slides that are games that allow students to work individually or with a partner or even a group. Let's take a look at the first one. The first post-assessment allows students to race one another. This also has sound. Let's say we're working with one other person. We can choose our character, and we answer the problems as we go through. Now these are multiple choice problems, and they are also true and false problems. If they get them correct, they move at a faster pace around the track. If they get them incorrect, they are pushed back. As we can see here. The next post-assessment has the exact same questions embedded into the game. This is a game show where students take turns answering questions. If one person gets it incorrect, the next person is allowed to take over that question and answer it on their own. This also has sound. We start by spinning the wheel to tell us the number of points that we will receive for the problem. Person A goes first by answering the true or false question. If they get it correct, that number of points is added to their goal. The next person goes next, and we repeat this process over and over until we see who receives the most credit in the end. So going back to the beginning, my self-assessment of this project is just my achievements was working with technology and being able to embed them into these slides. My challenges were not being able to help students, as I wanted them to truly work on their own and have their choices on their own. And finally, my breakthroughs was being able to see students truly work hard at understanding ratios and rates and exploring technology on their own.